Now the first, when we start with atoms, the first few things that we come across are basic old theories related to matter and all. So I'll introduce you to these theories. This is the first theory as we consider, called Dalton's theory. Of course, Dalton's theory is of matter, and Dalton's theory has some few points, out of which I'll just mention a few which are required. All matter is made of atoms. Atoms are indivisible and indestructible. So that means all the matter is made up of atom. That means the building block of matter, whatever matter you see, whatever material you see, the building blocks of that material are atoms. The smallest fraction of that material is atom, and you cannot further divide them and you cannot destroy them. This is the idea put forward by Dalton. Okay. All atoms of given element are identical in mass and properties. So this is what you can consider as common sense, that if a material has X number of particles, or say N number of particles, all of them must have same properties and they must be identical to each other. So different materials will have different atoms. Each atom is electrically neutral. Okay. Then compounds are formed by combination of two or more different kinds of atoms. This is Dalton's idea, very old idea. Dalton's idea, when I say Dalton's idea, Dalton कौन से जमाने का इंसान था वो भी पता कर लो. You know that? Dalton was in which century or कब? So we are talking about somewhere around 1800, 1800, 17 and something, and then beyond that. So 1800 के आसपास की बात कर रहे हैं हम. So we were not having modern theories. This is the first theory that we just go through. A chemical reaction is rearrangement of atoms. That is what his idea was. And then in original theory, you can see some more points which I don't consider here. I don't need that. Okay. Then what are the drawbacks? What are the drawbacks of this theory? So drawbacks of this theory come forward when Sir J.J. Thomson proved the existence of negatively charged particle. Okay. ये कब की बात है? ये बात चल रही है आपकी. I'll just write it. This is somewhere around 1766 to something 18 something. Okay. I can get precise number also. 1844. He died in 1844. So he lived long actually. Okay. So 1766 to 18. While this experiment was done in, or the results were published in 1897. So we're talking about this. So atom is divisible, and hence you can write all the other drawbacks, because once you know that there is something inside the atom and you can actually take it out, then it's not the same case as considered by Dalton. Then Thomson put forward another model of atom. This another model of atom is called Plum pudding model of atom. In this model, what Thomson did, Thomson considered an atom which is positively charged and negatively charged electrons are distributed randomly inside. You may imagine it like what you call watermelon. So the entire watermelon is assumed to be the atom. Then it is positively charged, and the negatively charged electrons are randomly distributed like seeds of the watermelon. Now this appears like plum pudding. So hence the model is referred as plum pudding model. We don't have to study anything about this. Drawbacks of this model. Then drawbacks of this model. I'm just giving you some introduction. So Sir Ernest Rutherford, in his gold foil experiment, we know this experiment. ये हमें स्कूल में भी सिखाया जाता है, alpha particle scattering experiment, which was performed by his students Geiser and Marsden. Okay. Okay. Under the guidance of Sir Rutherford, found the most found that most of the alpha particles fired on a thin gold foil. I hope you remember that gold foil experiment. It is there in your school syllabus also. Gold foil passed through it undeviated, while very few got deflected through very small angles and hardly any rebounds back through 180 degree. So this is not expected if the atom looks like the atom suggested by Plum pudding model. So it was not expected to have this kind of result. Now, Rutherford, after he did studying this experimental results and analyzing it, put forward his own model. Now, in his own words, what he has entered in his diary, actually, I'll just put this in his own words. You can read. This is what he has written in his diary. It was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. He's talking about that rebound of alpha particle from gold foil. On consideration, I realized that this scattering backward must be the result of a single collision. And when I made calculations, read it carefully. He's saying that when I made calculations, so he had to do some calculation. I saw that it was impossible to get anything of that order of magnitude unless you took a system in which the greater part of the mass of the atom was concentrated in a minute nucleus. It was then that I had the idea of an atom with minute massive center carrying a charge. Okay. Now this led Rutherford, this observation led Rutherford to another atomic model which resembles solar system, hence called planetary model of atom, and it is given as follows, and these are the points in his atomic model. First, atom consists of a centrally located positively charged core called nucleus. Okay. Then what about the negatively charged electrons then? The negatively charged electrons revolve around the nucleus in different circular orbits. The necessary centripetal force is provided by electrostatic force of attraction between negatively charged electrons and positively charged nucleus. So how do those electrons revolve? Then those electrons revolve because of that electrostatic attraction. Okay. The size of the nucleus is very small. The radius is approximately of the order of 10 raised to minus 15 meter. This is quite smaller. This is of the order of 10 raised to minus 15 meter. Okay. This is of the order of 10 raised to minus 15 meter to 10 raised to minus 14 meter. This is very small radius of the nucleus. Right. As compared to the total size of atom. Now, total size ka radius of the atom means what is the radius? So it is of the order of, now here we are writing everything in order of magnitude, not exact values. It is of the order of 10 raised to minus 10 meter. So angstrom ke scale. Thus, atom is practically hollow. See, atom is the building block of material. Hence, what is inside the atom? Then there is nothing, just space. Okay. Next, the total negative charge on electrons revolving around the nucleus is equal to the total positive charge on the nucleus. Thus, atom is electrically neutral. And this model satisfactorily explains the observations of alpha scattering experiment. Because when you consider the atom to be hollow, most of the alpha particles will not collide with anything and they will pass through. Hence, the result that most of it they pass through. So this is Rutherford's model, and it can definitely satisfactorily explain the results. As you are saying that atom is hollow, most of the alpha particles will pass through straight. Since the nucleus is heavy, very heavy, as compared to the remaining atom, almost entire mass is concentrated at the nucleus. You can actually add that point here. Almost entire mass of the atom is you can make this point. This was Rutherford's observation, and after calculations, he concluded this. Now, with this model, you can actually explain the results of alpha scattering experiment. but still there are some problems. Now, what are those problems? You can satisfactorily explain the results of alpha scattering experiment. So you can now discard the Thomson's model and you can hold on to this model. But now ये कब की बात है? Rutherford's experiment कब की बात है? You should know this up, क्योंकि उसके बगैर आप ये पता नहीं कर सकते कि ये कब हो रहा है. ये Rutherford कौन से जमाने का आदमी है? Is Rutherford's atomic model ये है 1871 to 1937. ओके, ये अर्न्स्ट रदरफोर्ड कब का आदमी है? 18, जस्ट फॉर द सेक ऑफ अंडरस्टैंडिंग कि क्या चल रहा है, आपको ये ज्यादा जरूरी है. जस्ट पता करना, याद नहीं रखना, हिस्ट्री का पेपर नहीं लिखना है हमें. तो 1937 ये इस जमाने का आदमी है. ओके, 1897 टू 1937 ये इसका एक्सपेरिमेंट कब है? 1897. ओके, सो 18, सॉरी हियर इट इज 1871, माय मिस्टेक. सो ये कब का एक्सपेरिमेंट है? 1897 का रिजल्ट है. ये 1871 से 1937 में ये कुछ कर रहा है. एंड देन देयर कम्स अनदर फेलो कॉल्ड मैक्सवेल. अब ये मैक्सवेल कौन से जमाने का आदमी है वो भी देखते हैं. पहले तो ड्रॉबैक देख लेते हैं. नाउ ड्रॉबैक, इसमें ड्रॉबैक सबसे बड़ा ये है दैट सिंस इलेक्ट्रॉन इज अ नेगेटिवली चार्ज पार्टिकल and when in orbit it is in accelerated motion. According to Maxwell's theory of electromagnetism, it must radiate energy in the form of electromagnetic wave. Now ये मैक्सवेल का थियरी है, और ये मैक्सवेल कौन से जमाने का? जेम्स क्लर्क मैक्सवेल कौन से जमाने का आदमी है? सो ये थियरी उसने उसके बीच में अपने लाइफ टाइम के बीच में दिया होगा. आई एम जस्ट कॉपिंग इट नाउ बिकॉज आई कैन नॉट रिमेम्बर द थिंग्स लाइक दैट. वो हिस्ट्री पढ़ते वक्त ये बस आपको समझाने के लिए याद रखना है. बता रहा हूँ कि वो कब कौन क्या कर रहा था, सो दैट यू कैन अंडरस्टैंड समथिंग कि कैसे होता है ये सब. से ये जेम्स क्लर्क मैक्सवेल वो उसी जमाने का, रिलेटिवली उसी टाइम स्पैन का आदमी है. जेम्स क्लर्क मैक्सवेल वाज इन और ऑन दिस अर्थ बिटवीन 1831 टू 1879. 1831 टू 1879. तो ये थियरी, इसका थियरी भी आपके पास ऑलरेडी है. दिस थियरी इज ऑलरेडी देयर विथ यू. ये बंदे ने जो थियरी दिया ये ऑलरेडी है. ओके, और अभी गड़बड़ है बिकॉज हिज थियरी सेज एन एक्सेलरेटेड पार्टिकल having charge radiates energy in the form of electromagnetic wave. Now, if you accept this, then due to this loss of energy, it will be continuous loss of energy because it is continuously revolving. So due to this loss of energy, the electron cannot maintain the distance from the nucleus, and hence it will follow a spiral path of gradually decreasing radius and ultimately falls into the nucleus. Thus, atom can never be stable because stability loss हुआ आपको. As you say that electron is a charged particle and in orbital motion, means it is revolving around the nucleus in circular orbit. Then, since it is a charged particle, and Maxwell's theory suggests that, and even at that time it was already experimentally established, the fact that every charged particle, if it is accelerated, radiates energy in the form of electromagnetic wave, and then we have a problem. Okay, so this tells us that electron cannot revolve in orbit without radiation, and if it does so, then it will definitely follow a spiral path instead of following circular path continuously. Moreover, there is one more point in that Maxwell's theory. Also, according to Maxwell's theory, the orbiting charge radiates energy or radiates electromagnetic wave having same frequency as that of the revolution of the charge. Means charge is performing 1 revolution per minute or per second, then the electromagnetic wave you are getting must have the same frequency as that of the charge revolving. So this gives us the next point, next analysis. Hence the electron, which is now in spiral orbit of decreasing radius with constant speed, okay, must radiate energy in the form of electromagnetic wave having gradually increasing frequency. Now, why gradually increasing frequency? Because it is moving with constant speed and decreasing radius. Okay, so the frequency goes on increasing because it takes less time to complete that circle as the radius decreases gradually. Okay, so as the radius decreases gradually. So fine, thus the spectrum of an atom must be continuous spectrum. That means there must be all wavelengths present from minimum to maximum. Now this is what we predict using Maxwell's theory or applying Maxwell's logic to this electron. But it is observed that atomic spectra means spectrum of atoms, different, each atom के लिए अगर आप check करोगे, are line spectra. Okay, so that means they have discrete lines representing particular frequencies of or wavelengths radiated. So you don't see all the wavelengths like this. I'll just show you what is continuous spectrum and what is continuous spectrum. Then continuous spectrum looks like this. Say, continuous spectrum looks like this. It is continuous. There's no gap. There's no gap. There's nothing missing. Okay. While atomic spectrum, I'll just show you visible part of atomic spectrum. ये continuous spectrum है. So you can see the visible part of atomic spectrum. और वो ऊपर वाला continuous spectrum है. So can you see that? This is the visible part of spectrum that we generally get. ये first वाला जो है वो hydrogen है. You can see 4 lines in visible part. उसके नीचे वाला helium है. You can see 7 lines in visible part. Right? 7 or 6, 7 lines. Then below that you have mercury, which has even more lines. And then you go for uranium in visible part, you can see entire barcode-like structure. Now this shows that the spectrum is not like this. This is what is expected if you apply Maxwell's theory. And the problem is it was already verified. Means the theory was already verified with experiments that whatever Maxwell said, that accelerated particle radiates or accelerated charged particle radiates energy in the form of electromagnetic wave. And if it is in circular motion, then the frequency of radiation is same as the frequency of revolution of charge. तो फिर ये होना ही नहीं चाहिए. In fact, atom stable ही नहीं होना चाहिए. These are the two drawbacks. Now we have a conflict here. एक part ऐसा है जो कह रहा है कि whatever structure we have predicted is absolutely fine as far as the experiment designed to test the structure is concerned. While thereafter we have a theory which says, oh, this is not possible because even if the structure looks okay, the problem is such electron or electron being a charged particle cannot do this without radiation. And if we try to check that radiation by doing by getting spectrum, then the spectrum must look like this, but instead the spectrum looks like this. Now we have a problem. Now this problem was solved by Niels Bohr. अभी एक बात याद रखना, बोर्स थियरी हम जो पढ़ रहे हैं वो बोर्स थियरी हम जिस ऑर्डर में पढ़ते हैं उस ऑर्डर में वो डिजाइंड नहीं है. मींस बोर केम टू द कंक्लूजन इन एग्जैक्टली रिवर्स ऑर्डर. ठीक है, यानी एक्सपेरिमेंट से स्पेक्ट्रम का एनालिसिस करके postulates तक, but we don't study it in that order. We study it from postulates to analysis of spectrum. ठीक है. So for this, Bohr took help of course, at that time it was very modern theory, Einstein Planck's light quantum hypothesis. ये कौन से जमाने का आपको शायद पता होगा, right? कौन से जमाने का है? This is in this is happening now around 1900 and 1900 and 1915 के आसपास की बात चल रही है, उस जमाने की बात चल रही है. ठीक है. तो light quantum hypothesis we have already studied, so I'm just mentioning the points here. First, light is propagated through space in the form of discrete packets of energy called photons. We have studied this. A photon behaves like particle of light, right? Photon travels with speed of light in vacuum. We have already studied it in detail. The rest mass of photon is 0. energy of each photon in a radiation of frequency nu and wavelength lambda is given by, and this is given by E is equal to hc by lambda, right? E is equal to hc by lambda. What is h there? What is h there? It is Planck's constant. This h is Planck's constant and its value is 6.63 into 10 raised to minus 34. That is what we use. Then momentum of photon is given by P is equal to mc is equal to h by lambda is equal to h nu by c is equal to E by c. And this theory, along with wave theory of light, can explain various phenomena exhibited by light, hence considers dual nature of radiation. This is what we have already studied, right? Now let's come to Bohr's atomic model. Of course, we start with the model as proposed by Bohr and we go towards the analysis of spectrum. While Bohr did analysis of spectrum, experimental results, and then he came back to this point, okay? So Bohr put forward the entire model of hydrogen atom. Now this is exclusively for hydrogen atom actually. In 3 points as such, we call them postulates. So the first postulate is nothing but the structure of atom, and this structure of atom is absolutely fine over here. If you consider this one, this structure of atom, whatever is proposed by Rutherford is fine, because structurally it gives you the same results or same prediction as you can observe those results. So इसमें कोई problem तो है नहीं. So Bohr accepted it. An atom consists of a centrally located positively charged nucleus. The negatively charged electrons revolve around the nucleus in different circular orbits. The necessary centripetal force is provided by electrostatic force of attraction between negatively charged electrons and positively charged nucleus. ये first point है. Now, if you take case of hydrogen atom, let's take case of hydrogen atom. Then what happens? In case of hydrogen atom, if we start like this, okay, I'll draw the diagram also. In case of hydrogen atom, if you look at this diagram, okay, and you consider that electron is moving with velocity v, electron is going with velocity v over here, ये v है, ठीक है? Then em is charge and mass, so let's write this as minus e and m. Minus e is negative charge, minus em, and that's the nucleus. And then there is radius को मैं r लिख देता हूँ. So this is the radius. Nucleus is supposed to be very small as compared to the orbital dimensions. Hence, you can directly measure it from the nucleus. No need to go to center of the nucleus. Okay. So then, if we know this, then since centripetal force is provided by electrostatic force, what do we do?
mv square by r equals to
square by r, or you can write it mv square by r is centripetal force and electrostatic force तो हमें पता है, तो we can write mv square by r is equal to this. Of course, I must write in magnitude because that charge is negative, so I'm not writing direction. So mv square by r is equal to 1 upon 4 pi epsilon naught e square by r square in magnitude. Now, for hydrogen-like atoms, if you take hydrogen-like atoms for solving problems, okay, then the charge will be atomic number times charge on electron on nucleus, okay, and only one electron in orbit. Then all you need to do is just put z there and you write the equation like this. This is what you commonly see in problems. They say doubly ionized lithium. Now doubly ionized lithium has only one electron, and then nucleus has 3 times charge on proton, so that will be 3e. So 3 is the atomic number of lithium, hence Ze, and we can solve any problem like this based on using that formula. Right now we'll study on the what do you say, this hydrogen atom. Hydrogen atom does not have that Z is 1, so we don't put Z there. So in first postulate, this is what we know. What about second? Now second postulate, now see where we have the problem in this original model put forward by Rutherford. We have problems when we try to apply this theory to that model. So structurally there was no problem, hence we are using the same structure here also. So Niels Bohr used the same structure, but to find out what happens with electron and how it can revolve without radiation. Of course, he did a bit of analysis and he concluded this statement. An electron can revolve in certain permissible orbits without radiation. So it cannot revolve anywhere, wherever it wants. Chalo, jaake ghumte, aisa nahi hai. It can revolve in certain permissible orbits. Now here, what do you mean by orbit? Orbit means distance from the nucleus. Okay. So certain permissible orbits, that means certain permissible distances without radiation, where the angular momentum of electron measured about the nucleus is integral multiple of h upon 2 pi, where h is Planck's constant. So this h upon 2 pi is also referred as h cross, read as h cross. h और ऊपर कट है वो t जैसा कट, t लिखते small t लिखते उसमें कैसा कट होता है वैसे. It is referred as reduced Planck's constant. And if that happens, that means if the angular momentum of the electron measured about the nucleus is integral multiple of a constant value h by 2 pi, then electron can revolve there without radiation. Otherwise, it won't. So your atom can be stable provided every electron in it satisfies this condition. Now, if we mathematically try to write down this condition for hydrogen atom, then what happens? For hydrogen atom, the magnitude of angular momentum about nucleus, let's say L, must be nh by 2 pi, where n belongs to natural number. Okay. Now, therefore, angular momentum to mvr hota hai. R is the radius of the orbit, v is speed and m is mass. So mvr is equal to nh by 2 pi. ये condition हम याद रख सकते हैं. This is the condition. This is what we can remember as condition. And if you satisfy this condition, n being a natural number, and what it tells us, then integer n is called principal quantum number. ये आपको शायद पता होगा, because this is what we always use in chemistry. This is called principal quantum number, and it designates the orbit number. यानी जिसे हम कहते हैं first orbit, second orbit, third orbit. That means first position from the nucleus where electron can be without radiation, then second possible position, third possible position. And here we have a tricky thing. It is combination of v and r, velocity and radius, yani velocity and distance, that determines where that electron can be. Okay, and it is integral multiple, so this thing is quantized. Quantized means it will be in multiple of some fixed value. So angular momentum is quantized, यानी आप कहीं पे भी randomly उसको नहीं रख सकते. This condition is called quantum condition, and it explains the stability of the atom, as the electron will not lose energy by radiation provided it satisfies this condition. So आपका electron अभी stably revolve कर सकता है, it will not radiate if it satisfies that particular condition. Okay. Now we have another problem. After giving this second postulate, we come across another problem, because according to second postulate, if every electron satisfies this condition, then there is no radiation possible. Now, if why it is so, that we'll see later on. Why it has to be that kind of thing. MVR is equal to nh by 2 pi and n being a natural number. ये सब ऐसा क्यों होना चाहिए? That we'll see later on. But time being, तो हमें इतना पता है कि ऐसा होता है. Now, this gives rise to another problem. That problem is, if electron is not, means if energy is not radiated by atom, then how do we get spectrum? Because if energy is not radiated, then you should not get any spectrum. कुछ भी नहीं. Neither line spectrum nor bar spectrum. कुछ भी नहीं. Oh, sorry, nor continuous spectrum. कुछ भी नहीं. So there must be radiation of energy, and Bohr give us this postulate for that. Energy is radiated if and only if an electron jumps from higher orbit is higher energy level here, to a lower orbit. The energy radiated in the form of photon during such transition of electron is equal to the energy difference between the two energy levels. So what Bohr is saying now, if electron jumps from higher orbit to lower orbit, that means higher permitted distance comes to lower permitted distance, then energy is radiated. And of course, he is saying if and only if, so there is no other way for electron to radiate energy or lose energy. This is the only way. And if it does so, then definitely you will get a photon out there. for hydrogen atom, if EI and EF are energy levels of electron in nth and nth, I and F I'm using for initial and final orbit. So orbit, during its transition from nth to nth orbit, the energy radiated is equal to the energy difference between the two. So E is equal to EI minus EF, and E is h nu. So you can write h nu is equal to EI minus EF. Now, since EI and EF are constants, we get one particular frequency nu radiated during this transition, resulting in one corresponding line in spectrum. यानी आपको एक ही आंसर मिलेगा nu का. So you get only one line corresponding to that one color, one particular line. So that's how we can say कि okay, ऐसे transitions होते रहे, then we get a spectrum that has only lines, and there is no possibility of getting spectrum which has continuous distribution of all energies or all wavelengths. So this condition is called frequency condition, and it explains atomic spectrum. We call it emission spectrum. And of course, you will have to note this point again. During the transition of electrons from lower to higher orbit, the energy equal to the energy difference between the two levels is absorbed, leads to absorption spectrum. यानी आपने समझो white light allow किया, white light is incident on some gas, say hydrogen, और उसके अपोजिट साइड में यू हैव अ प्रिज्म, जो व्हाइट लाइट बीम है, बीच में हाइड्रोजन है और सामने एक प्रिज्म रखा और उसमें से स्पेक्ट्रम एनालिसिस करने की कोशिश की, देन यू विल सी दैट ये स्पेक्ट्रम ऐसा ही दिखेगा, बट इसमें से ये वाले लाइंस एब्सेंट होंगे. सो देयर विल बी डार्क लाइन, यानी ये रेड दिख रहा है ना, ये रेड मैचिंग कहाँ पे है, वो वाला पार्ट एब्सेंट होगा. ये ब्लूइश दिख रहा है, ये ब्लू कहाँ पे मैचिंग, वो वाला पार्ट एब्सेंट होगा. ये पर्पल वायलेट जो भी दिख रहा है वो वाला पार्ट एब्सेंट होगा, बिकॉज दैट photon has been absorbed. So it is no longer present in your white light. Okay. So this is the way you get the other type of spectrum, that is called absorption spectrum. The important point here is very simple. If electron jumps from higher orbit to lower orbit, it radiates energy. Then if it has to go from lower orbit to higher orbit, it will absorb energy. And how much energy is radiated or absorbed? So it is equal to the energy difference between the two energy levels. Okay, respectively, itna hona chahiye. Fine. Now you go through this Bohr's atomic model once, and then we can proceed to the next part. Go through it once. So now let's come to the next thing. Next thing is, let's try to calculate the radius of nth Bohr's orbit. Now, what do you mean by nth orbit? Nth orbit is like n is principal quantum number. So first orbit is the smallest distance where electron can be without radiation. Then second orbit becomes the next possible distance, and then next possible distance. And these distances are quantized. That means electron cannot be at 1 times some distance x and then 1.1, 1.2, 1.3. No, it will be either at 1 times x, then 2 times x, then 3 times x. It is that kind of thing. Okay. So let's see whether we can find this or not. Okay. So for hydrogen-like atom having Z, now what I am doing is I'm actually calculating everything for hydrogen-like atom. But what you can do is you can calculate everything for hydrogen atom. Always, when you are writing theory papers, always read the question carefully. If they specifically say do it for hydrogen atom, you don't have to write that Z. Remember, okay? Now I am generalizing it with hydrogen-like atom, but original theory is only for hydrogen atom. So you do not have Z in that theory. Okay, Z becomes 1. So for hydrogen-like atom having charge plus Ze on nucleus and having only one electron in nth orbit of radius Rn, moving with speed Vn, if that is what we have, then from Bohr's first postulate we get, now we know the postulate, so we get m Vn square upon Rn is equal to 1 upon 4 pi epsilon naught Ze squared upon Rn square. Okay. And from Bohr's second postulate, what we get? From Bohr's second postulate, we know that mvr is equal to nh upon 2 pi. So I am writing mvn rn is equal to nh by 2 pi. Vn rn मैंने ऊपर first line में mention किया. Rn is radius and Vn is speed. So we have these two. Then can we calculate radius? Then we can do it like this. See, if I square both sides of equation 2, that is squaring equation 2, I can actually get Vn square, right? If I square equation 2 and then try to get Vn square, I can get Vn square. So Vn square is equal to n square h square upon 2 pi the whole square. Then left hand side का m square right hand side में डिनोमिनेटर में लिखना है, एंड लेफ्ट हैंड साइड का Rn square बन जाएगा स्क्वायर करने के बाद, उसको भी राइट हैंड साइड पे लिखा है. Then once I get this, I'm actually going to substitute this Vn square. You can use any algebra, any kind of things you can do substitution करके. What I'm going to do is 1 and 2, 1 and 2 नहीं, 1 and 3 I should have said, because I'm marking it as 3. So from equation 1 and 3, I can actually substitute Vn square का value in that equation. So I've substituted it directly. And with substitution, then what is left? Only the algebraic steps. So just do the algebra. So Rn is equal to epsilon naught n square h square upon pi m z e square is now the value. So what I can do is I can write Rn as epsilon naught h square upon pi m e square n square upon z. Now here, if you look at this value put in bracket, which is kept in bracket, that value is constant, because epsilon naught is constant, h is constant, pi is constant, m is constant, and e is also constant. Hence, you can say this radius of nth orbit is directly proportional to n square upon z. Now remember, here I am considering hydrogen-like atoms, so this is not true for real atoms. You might know that as atomic number increases, at some point you will see the radius goes on decreasing, total radius of atom goes on decreasing. ये तो आपने देखा भी होगा एक certain point पे. And this is but not applicable to real atoms, because उसमें बाकी के forces भी होते हैं, तो वो हम consider नहीं कर रहे. हमने consider किया एक ही atom, एक ही electron है, बाकी z कितना भी होने दो. So this is not directly applicable to all the atoms, but हाँ, you can treat it like that. For hydrogen atom, z is 1. So if you put z is equal to 1, then Rn becomes epsilon naught h square upon pi m e square n square. And therefore Rn can be written as directly proportional to n square. This is for hydrogen atom. Now also, if you try to calculate that constant, this thing, can you calculate that? Epsilon naught h square upon pi m e square. Can we calculate that? So that value is calculated like this. So also, मैं R1 calculate करके दिखाता हूँ आपको. R1 is into 1 square. This is into 1 square, of course, क्योंकि वो उसका स्क्वायर किए बगैर आएगा नहीं आंसर आपका. So what is the value of epsilon naught? It is 8.85 into 10 raised to minus 12. I am purposely writing units also. ठीक है. This is per coulomb square per Newton meter square, right? So minus 1, no? Coulomb square per Newton meter square. Okay. Then 6.63 into 10 raised to minus 34 joule second, squaring that, we get the actual value required. Pi into 9.1 into 10 raised to minus 31 kg into 1.6 into 10 raised to minus 19 coulomb. And if you try to solve this, we end up getting, if we solve this, arithmetics थोड़ा सा करना पड़ेगा. And if we solve this, we end up getting 0.529 into 10 raised to minus 10 meter, which can be then written as 0.529 angstrom. So Rn for hydrogen atom can be always written as Rn can be always written as 0.529 n square angstrom. Okay. Now this is for hydrogen atom, and for any other atom, hydrogen-like atom, it will be 0.529 n square upon z. So now I'm not writing that. Okay. It will be 0.529 n square upon z. Now look at this. If you just look at this and go through it carefully, आप इसमें जो चाहे अलजेब्रा करो, आपको सिर्फ एक काम करना है, v and n, क्योंकि ये कंडीशन देखिए इसमें, सॉरी, v and r दोनों साइमल्टेनियसली प्रेजेंट है, राइट? सो आप इसको किसी भी तरह से रेडियस फाइंड करते हो, उसमें v नहीं होना चाहिए, और v फाइंड करते हो उसमें r नहीं होना चाहिए. उतना ध्यान रखो बस, बाकी कुछ नहीं करना है. So when you are trying to find out radius, you try to get rid of v, and when you are trying to find out v, try to get rid of rn, sorry. So this is how we get the answer. Now what we can do, what else we can do? We can try to find out what is the velocity. Can you find velocity? So now you try this one. Say, let's try to find out velocity. Now if we have velocity in nth Bohr's orbit of hydrogen-like atom, बाकी सारे वेरिएबल्स सेम है, तो ये फर्स्ट 4 लाइन में सेम लिखूंगा, exactly the same. ये ये 4 लाइंस को सेम कर दो, सेम टू सेम, बिकॉज फर्स्ट पोस्टुलेट से मुझे क्या मिला, सेकंड पोस्टुलेट से मुझे क्या मिला, मुझे पहले से पता है, राइट? नाउ इफ वी हैव दिस विद अस, कैन वी सॉल्व इट फॉर वी? तो वी सॉल्व करने का मतलब है यू शुड गेट रीड ऑफ आर एन, रेडियस गायब करो उसमें से किसी तरह से. सो वी कैन डू इट जस्ट बाय डिवाइडिंग. इफ वी डिवाइड these equations, what we get mv, उसमें आर एन है ना, तो डिवाइड करके मैंने आर एन एक साइड में लेके आया, मैं आर एन स्क्वायर हो जाएगा, दूसरे साइड में आर एन स्क्वायर ऑलरेडी है, सो इट विल गेट कैंसल्ड. सो यू कैन ट्राई दिस. आई हैव एक्चुअली डिवाइडेड this equation 1 by equation 2. आई एम जस्ट डूइंग अलजेब्रा. मैंने देखा है मुझे vn फाइंड करना है, तो rn को किसी तरह से हटाना है उसमें से, और rn को हटाने का क्या तरीका हो सकता है, तो आई एम डिवाइडिंग इक्वेशन 1 by इक्वेशन 2. द मोमेंट आई डू दैट आई विल गेट rn स्क्वायर, ये दोनों साइड में, राइट? सो आई कैन गेट रीड ऑफ rn स्क्वायर, एंड दिस लीड्स अस टू v का वैल्यू विच इज z e स्क्वायर अपॉन 2 एप्सिलॉन नॉट hn. So V can be written as, you can do the same things, e square upon 2 epsilon naught h is constant, उसको बाजू में निकाल दो और लिखो V का क्या प्रोपोर्शनैलिटी है. तो V is proportional to Z upon N. For first orbit of hydrogen atom, you can substitute the values and we'll get the numbers. If we substitute Z is equal to 1 and N is equal to 1, then V1 is equal to e square upon 2 epsilon naught h, which is 2.18 into 10 raised to 6 meter per second. Okay, so electron is moving with quite a large speed, 2.18 into 10 raised to 6 meter per second, and you can see that कि ये बहुत सिंपल होता है बट अल्जेब्रिक होता है पूरा. These derivations are asked in your board exams, so be careful about these derivations. Now this is for you. This is for you. इसे सॉल्व कर पाओ तो can you solve that? Try to find out angular velocity of electron in nth Bohr's orbit of hydrogen atom or hydrogen-like atom. Now do this. पॉइंट्स तो आपके सामने लिखे हुए. Vn is already known and Rn is known. You can directly make use of that. चलो try. So as we know, for circular motion, V is equal to R omega. So since electron is in circular orbit, you can actually put all those values right there, and we end up getting the expression that looks like this. Of course, here nothing is getting cancelled, so your expression looks like pi m e raised to 3 z upon 2 epsilon naught square h cube n cube, this type of expression. It has n cube in denominator, please remember. And since pi m e cube upon 2 epsilon naught h cube is constant, we can always write omega n is z upon n cube. And for first orbit of hydrogen atom, you can definitely calculate the things if you want. And the answer is 4.121 into 10 raised to 16 radian per second. Similarly, we can calculate centripetal acceleration as we know V and R. Okay, as we know V and R, this part remains the same for all. V and R is known, then what is centripetal acceleration? Centripetal acceleration is V square upon R. So just do that, and V square by R results in this. V square by R, if we do V square by R, knowing the values according to Bohr's theory, acceleration becomes pi m e raised to 6 upon 4 epsilon naught cube h raised to 4 into z square upon n raised to 4. Now again, since that value there, pi m e raised to 6 upon 4 epsilon naught cubes h raised to 4 is constant, acceleration is proportional to z square upon n cube. And for first orbit, again, you can calculate it and we end up getting this answer. If we calculate that, answer is 8.984 into 10 raised to 20 meter per second for hydrogen atom. So you can put it here, right? And Z is 1, and you can actually get the value for any other orbit. You will have to remember these values and proportionalities as far as your exams are concerned. In most of these entrance exams, we keep on using these proportionality statements to get values in first and fifth and seventh and so on. So those values, those things are very important. Now let's try to find out energy of electron in nth Bohr's orbit. Of course, I'm doing it for hydrogen-like atom, not for hydrogen atom. So I'll always have that Z in there, okay? So since the electron is moving, definitely it possesses kinetic energy given by, now kinetic energy is given by half mv square. हमें पता है वो, okay? So half mv square में हम एक काम कर सकते हैं, हमें पता है v क्या होता है. So according to Bohr's theory, v is z e square upon 2 epsilon naught square epsilon naught hn. डायरेक्ट सब्स्टिट्यूशन ही कर दो, कुछ दिमाग नहीं चलाना. If we substitute it directly, what we end up getting? We get kinetic energy is half m and that substituted value ka square. Solve it, simplify, and simplification gives us this thing. Kinetic energy is equal to mz square e raised to 4 upon 8 epsilon naught square h square n square. That is what we get. Now what is this? This is kinetic energy. Also, electron is in the electric field produced by the nucleus, right? So since electron is a charged particle and it is in the field produced by nucleus, positively charged nucleus, its potential energy is given by electric potential at distance Rn due to charge on the nucleus. Charge on the nucleus is Ze, right? Charge on the nucleus is Ze. I'll just write that also, plus Ze, multiplied by charge on electron, and charge on electron is actually minus E. So if you write that इलेक्ट्रिक पोटेंशियल, हमें पता है कूलॉम्स लॉ से हमने सीखा है ये सब. So electric potential is calculated as 1/4 pi epsilon naught d0 epsilon naught charge upon distance. So charge is Ze upon distance is Rn, and charge on electron is minus E. So just put it there and then simplify this. So if we simplify that, we get potential energy is 1/4 pi epsilon naught Ze square upon Rn. The negative sign here indicates that the force between the nucleus and electron is attractive. हमें पता है, हम ऐसे करते हैं जब attractive force होता है तो negative potential energy लिखते हैं, because system attracts, system work does the work, and hence system loses energy, तो हम negative लिखते हैं, right? Also according to Bohr's theory, this R has a value which is epsilon naught h square upon pi m e square into n square. तो एक काम कर लो, इसे ऊपर substitute कर दो and then simplify it further. So if we substitute that value and simplify, we end up getting this. Potential energy is equal to minus m z square e raised to 4 upon 4 epsilon naught square h square n square. That's what we get. Now we want to find out total energy. So दो ही energies है electron के पास, so total energy will be simply sum of the two. So if we do this, ऊपर के दोनों values लेके solve कर लो, तो final answer becomes this. Total energy is minus mz square e raised to 4 upon 8 epsilon naught square h square n square. Now उसको भी फिर से मैं वही करता हूँ. I will write it separately like this. Z square n square separate करके लिखता हूँ. So we know that since this m e raised to 4 upon 8 epsilon naught square h square is constant, we can always write total energy is proportional to z square upon e square, but with the negative sign. Okay, remember, it has a negative sign there. That constant will not be negative. Now, for hydrogen atom, as usual, I'm following the same steps now. Again, for hydrogen atom, put those things to be 1 and substitute the numbers, numerical values, and try to calculate it. And when we do this, it results in this number, minus 2.1653 into 10 raised to minus 18 joule in joules, and dividing this by charge on electron gives us value in electron volts. So let's write that value also, divided by 1.6 into 10 raised to minus 19, and we get this minus 13.6 electron volt. Okay, so minus 13.6 electron volt is the value that you can actually substitute and write energy of electron in any orbit for any hydrogen-like atom, provided you know Z and the orbit number n. So you can just put this value at that constant value. Okay. Now, what is the significance of negative sign here? What is the significance of negative sign here? The negative sign indicates that the electron is bound to the nucleus by electrostatic attraction. याद रखना ये. Negative sign here indicates that negative sign to the potential energy indicates that the force between the nucleus and electron is attractive, while here indicates that it is bound to the nucleus. ये exactly same logic हमने पहले use किया है, याद आया क्या? Satellite में, satellite, orbiting satellite. Okay, since the total energy of electron is negative, it increases with increase in principal quantum number. Okay, negative and inversely proportional Negative and inversely proportional to the principal. वो नेगेटिव भी है and it is inversely proportional to the principal quantum number. It increases with increase in principal quantum number. यानी जैसे आप you can see this, you can try this one. इसका फर्स्ट ऑर्बिट एनर्जी हाइड्रोजन का है -13.6. व्हाट विल बी द सेकेंड ऑर्बिट एनर्जी? तो सेकेंड ऑर्बिट एनर्जी विल बी एक्चुअली -13.6 डिवाइडेड बाय ये n स्क्वायर करना है ना. नाउ n is 2, स्क्वायर करेंगे तो 4. So -13.6 divided by 4 gives us -3.4. And -3.4 is a larger number. It is on the right hand side on the number line. Right hand side of 13.6, -13.6. Then you move to the next one. So if you do divided by 9, you get 1.5 and something, 1.51. So that is even greater, even though the number looks smaller, because it is negative number, it is on the right hand side of the previous number. Hence the value goes on increasing. Now what is happening due to this? What is happening due to this? Thus the electron in higher orbit possesses higher energy compared to the electron in lower orbit, but it is less tightly bound to the nucleus. Yani the increase in orbit number or principal quantum number actually decreases the strength of the binding जो भी है उनमें, इलेक्ट्रोस्टैटिक अट्रैक्शन है, जो भी जिस तरह का बाइंडिंग है, उसका स्ट्रेंथ डिक्रीज करता है. सो हायर ऑर्बिट का इलेक्ट्रॉन बाहर निकलना है आपको, इट इज मच इजियर कंपेयर टू द लोअर ऑर्बिट का इलेक्ट्रॉन. एंड दिस इज द लॉजिक दैट वी हैव बीन यूजिंग. हमें ये बचपन से सिखाया जाता है कि दिस इज हाउ इट वर्क्स. तो दिस इज द वे वी गेट दिस एनर्जी का एक्सप्रेशन. नाउ यू कैन गो थ्रू दिस एनर्जी का एक्सप्रेशन. एक बार ये जरा नोट डाउन करो तो ज्यादा बेटर है, ठीक है? एंड देन वी विल प्रोसीड टू द नेक्स्ट.